Hello everyone. I hope you all are doing very well. And in this session of AI interview preparation series, this is question number 9 that I am going to discuss. And the question here is, what are some common algorithms used for dimensionality reduction? So dimensionality reduction is a technique. Basically, it is used to reduce the number of input variables or features in a data set while preserving the most important information so that the conclusion can be made, but unnecessary features can be reduced, which is not of required, right? So this is particularly useful for simplifying data, speeding up the training time, and improving the performance of machine learning algorithms by reducing the noise and redundancy in the input space, right? So I hope the definition is very easy and simple to understand, that basically we need to reduce the number of inputs and variable in the feature so that the original information or the most important features or information can be preserved, and we can simplify the process, we can speed up the training time of the machine learning algorithm, and we can enhance the performance, right? So there are some of the important algorithms for dimensional reduction, out of which one is PCA, that is principal component analysis, right? So principal component analysis is an algorithm. Basically, it is most widely used technique for dimensional reduction. It transforms the original variables into new set of orthogonal variables, that is into principal components that captures the maximum variance in the data. Now, all these important terminologies like principal component, variance, bias, already we have discussed in the previous 8 videos of this interview preparation series. So do watch them as well so that you cannot skip the important terminologies and important part, because already we have started from the basic concept, thereafter we go to the moderate, and now we are learning here, right? The thing is that already we have discussed so much things yet. So do watch the previous series, previous lectures. In the description section, link is mentioned, and then you can continue this so that all the important 10 questions could be there, and you can make a note of it, or you can just prepare it just by watching again and again, right? Okay. The principal components are ranked in order of decreasing variance, allowing for dimension reduction by selecting subset of top components, right? Okay. The second algorithm is T distributed stochastic neighboring embedding, that is called as TSNE, that is T distributed stochastic neighboring embedding. Basically, it is used for visualizing high dimensional data by projecting it into lower dimension. Means if we want to see the higher dimensional, multi-dimensional data with the help of lower dimensional space like 2D or 3D, for that we can use this nonlinear technique, that is TSNE. It preserves local structures and clusters in the data, making it ideal for exploratory data analysis and visualization, right? Now, TSNE is commonly used in tasks such as visualizing embeddings, learning by deep learning models, or exploring relationships in complex data sets. Now, the third one is linear discriminant analysis, that is LDA. LDA is a supervised dimension reduction technique that maximizes the separability between different classes in a data set. It projects the data onto a lower dimensional space while maximizing the between class scatter and minimizing within class. So we have already discussed that in LDA, basically there is two concepts, between class and within class, right? So between means multiple classes are there, within means same class, right? Linear discriminant analysis commonly used for feature extraction and dimensionality reduction in classification tasks. Okay. Autoencoders. So fourth important algorithm is autoencoders. Autoencoders are type of neural networks architecture which is used for unsupervised learning of efficient data codings in an unsupervised manner. Basically, they consist of encoder network that compresses the input data into a lower dimensional representation, that is latent space, and a decoder network that reconstruct the original input from the later representation, right? So by training the autoencoder to minimize reconstruction error and the latent space can capture meaningful features of the data, enabling dimensity reduction. The next one is isomap, that is isometric mapping. It is also one of the dimensity reduction technique which is used for geodesic distance in high dimensional space to construct a lower dimensional embeddings. It preserves global distance and neighborhood relationship in the data, making it suitable for data with non-linear manifold structures. One more is there, that is LLE, locally linear embedding. It is also one of the important dimensional reduction technique that preserves local relationships between data points, and it reconstructs each data point as a linear combination of the neighbors, preserving the intrinsic local structures of the data in the lower dimensional space, right? So ultimately, one more is there, that is feature selection technique. While not strictly dimensional reduction algorithm, feature selection methods such as recursive feature elimination RFE or feature importance from ensemble models, for example random forest, can effectively reduce dimensity by selecting most relevant features for the given task. So conclusion we can make is these dimension reduction algorithms play a crucial role in pre-processing and feature engineering pipelines, which helps to improve the performance, interpretability, and efficiency of machine learning models on high dimensional data sets. The choice of algorithm depends on the specific characteristics of the data and the objectives of the analysis or modeling task, right? So I hope this particular question of dimensional reduction technique, basically the question was how many different dimensional reduction techniques are there. So one is feature selection technique, locally linear embedding, isometric mapping, autoencoders, linear discriminant analysis, T-distributed stochastic neighbor embedding, and principal component analysis, all about reducing number of input variables and features while preserving important information for simplifying data, speeding up the training time, and improving the performance, right? Guys, do subscribe, stay tuned for more such video lectures. Have a very nice day. Jai Hind, Jai Bharat.